Hello everyone, welcome to my channel The Physics Chronicles. Since last few months I have been receiving a lot of requests to start the lectures on SSB exam. So here I am uploading the first lecture of this series, which will be on mathematical physics. So before starting the lecture, let's go through the syllabus of this mathematical physics, which I have taken from I guess last year's syllabus. So it consists of vector calculus, which includes Gauss divergence theorem and Stokes theorem as well. Then there is a tensor, and we will go to complex variables after that. We will be talking about Bessel, Legendre, and Hermann differential equations, and we will wrap it up with beta gamma function, Fourier series, direct delta function, and Laplace and Fourier transform. So before jumping into the syllabus, it is always good to talk about few basics. So what is a vector? Vector is a physical quantity which is specified by a magnitude and direction. Provided to these two, magnitude and direction, they should follow the law of vector addition as well. Now the question is, what is law of vector addition? So if I have two vectors, one is specified as P and another one is specified as Q, then the addition of these two can be R vector. The angle between P and R is phi, but the angle between P and Q is theta, right? So we can write down the resultant R is equal to P vector plus Q vector. This is the law of vector addition. If you try to find out the magnitude of this vector, then it will be P square plus Q square plus 2PQ cos theta, the angle between P vector and Q vector. And if we try to find out the angle between P and R, then it will be tan inverse Q sine theta divided by P plus Q cos theta. So how this formula is written here? See, this is phi. Tan phi will be this right here, this divided by this right here, right? This is the height. This is Q vector. This one is Q vector. So this will be Q sine theta, and this part will be Q cos theta. This part will be Q cos theta. So the whole base will be P plus Q cos theta, and this height will be Q sine theta. So phi becomes tan inverse Q sine theta divided by P plus Q cos theta. Now there are different types of vectors like null vector, which has zero magnitude and no particular direction. We can call a point as a null vector, or any physical quantity which has initial and final point coinciding at the same point. We can call that as null vector. Then we have this unit vector which has a magnitude of unity, like it has unity magnitude. So we can write it down as, let's say we have a vector A, its unit vector will be A cap, written as A vector divided by magnitude of A vector, right? Then we have collinear vectors, that is two or more vectors which is parallel or anti-parallel with each other. That is two or more vectors which can make angle 0 degree with each other or can make 180 degree with each other. Then we have coplanar vectors, vectors which lie in a same plane. Let's spend a few minutes here. What is the coplanar vectors? So the condition of coplanarity, we usually write it down as, let's say we have three vectors, A vector, B vector, and C vector. If these three vectors are coplanar, then they must satisfy the condition A vector dot B vector cross C vector must be equal to 0. which in terms of matrix formation we can write it down. Let's say my A vector is A1 I cap plus A2 j cap plus A3 k cap. B vector is equal to B1 I cap plus B2 j cap plus B3 k cap. Similarly, C vector is equal to C1 I cap plus C2 j cap plus C3 k cap. Now in matrix form, it can be written as A1, A2, A3, B1, B2, B3, C1, C2, C3. This determinant will be 0. Sorry. This determinant will be 0. Then only it will be called as coplanar. If this is not equal to 0, then these three vectors don't lie in a plane. Now the point is, from the quantum mechanics, you must be aware of basis vectors. So if this A, B, C are coplanar, then they are linearly dependent vectors. So if A, B, C are coplanar, it is if they lie on the same plane, they are linearly dependent, right? So they can't form a basis. But if the same three vectors are non-coplanar, then they are linearly independent vectors and they can form a basis, right? Remember this point. This is very, very important, right? And lastly, we have this reciprocal vector. If we have two vectors, they will be called reciprocal if they have same direction, but their magnitude is reciprocal to each other. Like if I have a vector A, it is lambda n cap, the direction is along n cap. Then I have another vector B, which is called as reciprocal vector to A. Then it will have a magnitude 1 by lambda, but direction will be same as A. So now let's come to this dot product. What do you mean by dot product? Simply we write down dot product as A vector dot B vector is equal to AB cos theta, right? We write it down like this. So what is the geometrical interpretation of this dot product? If I have these two vectors, like this is, for example, this is A vector and this is B vector. Now break down this equation. It becomes A into B cos theta. If these two have an angle theta, then B cos theta will be which component? This one. If I draw a it is 90 degree. If I draw a height to this perpendicular height to this A vector, then this will be B cos theta, this distance, and this part will be B sin theta, right? So we can write it down as A into B cos theta. It means the magnitude of A, or the length of A, is multiplied with the length of projection of B in direction of A. We can write it down as length of A multiplied by length of projection of B along direction of A, right? So there are few properties of this dot product, like they are commutative and okay, so let me write it down. A dot B is equal to B dot A, and if I multiply a scalar with it, B is equal to MA dot B, that is equal to A dot MB. Okay, so now let's take a few special cases, like if theta is 0 degree, then A dot B, that is AB cos 0 is equal to AB, right? If theta is 90 degree, then A dot B is equal to AB cos 90 degree, that will be 0. And if theta is equal to 180 degree, then A dot B is equal to AB cos 180 degree, is minus AB, right? This is all about the dot product. Now let's move on to cross product and what is its geometrical interpretation. Now mathematically we write it down as A vector cross B vector is equal to A B sin theta n cap. Now this n cap is the direction perpendicular to the plane containing both A and B. This is a very basic things, right? So the direction of this cross product is perpendicular to the plane which contains both A and B, right? If I have two vectors like this is A, this is B, and there is angle theta between them, then okay, so this is the plane, sorry. So this is the plane. The direction of n will be perpendicular to this plane. Let's say this is xy plane. So depending upon our cross product, it will be either along m direction, n cap, or along minus n cap. Okay, so if we go like this, A to B, like the cross product is A cross B, then the direction will be n cap. And if we go like B to A, that is B cross A, then the direction will be minus n cap. Now what is the geometrical interpretation of this cross product? So if we take this A vector and B vector here, and these are the sides of the triangle, let's take this point O, right? This is the sides of the triangle OAB, right? OAB. Now this magnitude of this cross product represents twice of the area of the triangle. Okay, so let's take the magnitude only, that is A B sin theta. So what is the value of B sin theta? This is angle theta, so sin theta will be the perpendicular height only, right? This is B sin theta. A is the base, right? So A is base into height. base into height, right? This part is clear. Okay, so now as you can see, the direction changes if we change the sequence. It is A cross B is equal to minus of B cross A. So this is non-commutative, right? Okay. So another thing, how can you find out the unit vector perpendicular to A and B from this? As you can see here, A cross B is equal to AB sine theta n cap. From this we can easily find n cap is equal to A cross B divided by magnitude of A into magnitude of B sine theta. This gives us unit vector perpendicular to A and B. Okay. I think this part is clear. Now let's see few of the examples or applications of this dot and cross product. As you know, the first example is the work done by a force causing a displacement dr. It is, we write down the work as F dot dr. It is work done by force F causing displacement dr. Second application is the flux of electric field E through a surface area ds. We write down the flux as E dot ds, right? That is flux of electric field E through a surface area. Now the third application is we can establish a relation between linear momentum and angular momentum. That is L is equal to R cross P, where L is angular momentum and P is linear momentum. Now the fourth application is relation between linear velocity and angular velocity. Like we can write down V is equal to omega cross R. And the fifth application is Lorentz force, force on a charged particle in a uniform magnetic field, that we can write down F is equal to Q V cross B, right? So these are the basic things. Now another thing, we'll end this lecture with this. Another thing is scalar triple product. Scalar triple product. That is A dot B cross C. I have already explained this one while explaining coplanarity. It is x component, y component, z component, bx component, by component, bz component, cx component, cy component, cz component. This and determinant. Alternatively, we also write it down as a vector, b vector, c vector. Okay. And the geometrical interpretation is it explains the volume of the parallel pipe. If A, B, C are three concurrent edges of a parallelepiped, then this A, B, C is the volume of this very parallelepiped. right? So these are all the things. Now from the next class we'll talk about this vector algebra properly. That is, we will go into the gradient, curl, and divergence of the vectors, and see few applications and solve some problems as well. So thank you everyone. So if you like this video, then just comment it, and you can also comment if you want to go through these basics, or we will directly go into the problems. Okay, thank you. See you in the next lecture.